Hi, welcome back to Moose and Chemistry. This is thermochemistry and specific heat and heat vaporization lesson number 1. How much energy is needed to heat 9 grams of H2O from 25 degrees Celsius to 85 degrees Celsius? Okay, well, let's look at what we know. We know that the specific heat formula is Q equals MCAT, right? So what we're going to do is we're going to go ahead and figure out what we need. We're looking for the energy. That would be Q is the energy. Our mass is 9 grams. Our delta T is going to be 60. How do we know it's 60 degrees Celsius? And I'm going to show you that in just one moment. And our specific heat for water room temperature is 4.18 joules over grams times Celsius. How do we get this 60 here? Well, delta T equals T of F minus T of I. So this is going to equal 85 minus the initial temperature, which was 25. And that will give me my 60 degrees Celsius. That's where that came from. Okay, great. So now we're just going to go ahead and plug in our formula, right? So Q equals 9.00 grams times 4.18, and that's joules over grams times Celsius, times 60 degrees Celsius. So Celsius cancels, grams cancel, and the Q value is going to equal 2,257 joules of energy is needed to change it from 25 degrees Celsius to 85 degrees Celsius. Okay, so let's look at the next problem. Okay, so the next problem says, what is the specific heat of 22.8 grams sample of a metal that absorbs 1,450 joules of heat from 21.8 degrees Celsius to 75 degrees Celsius? Okay, well, our Q value is going to be 1,450 joules, okay? That's our Q value. Our sample has a mass of 22.8 grams. And our delta T, now remember delta T is equal to T of F minus T of I. So delta T is equal to 75 minus 21.8. So our delta T is equal to, of course, 53.2 degrees Celsius. So we're going to put our 53.2 degree C here, and we're looking for our specific heat, which is C. Okay, now that means we're going to modify this formula. So this is going to be C equals Q over what I call MAT, M-A-T, well, M delta T actually. So C equals our Q, which is 1,450, okay, right, over our 22.8 times our 53.2. I'm just dropping the units off for now, guys. Don't panic. And I'll put the units back on after I do the math. So I do the math here, and I get 1.2 joules over grams times Celsius. Okay, let's look at our final problem in this lesson. What is the specific heat of a substance that absorbs 2.5 times 10 to the third joules of heat when a sample of 1.0 times 10 to the 4 grams of a substance increases the temperature from 10 degrees Celsius to 70 degrees Celsius? So let's go ahead and do our delta T first. Our delta T, of course, remember, equals T of F minus T of I. So delta T is going to equal our final temperature, which was 7 degrees, minus our initial temperature, so our delta T is equal to 60 degrees C. So our delta T is going to be 60 degrees C. Our mass is 1,000 grams. Our Q value is 2,500 joules. So all we have to do is set up for C. Again, C equals Q over, I call it MAC. It's M delta T. So C equals 2,500. And I'm going to put the units back on at the end, times the mass, which is 1,000 grams, times our change in temperature, which is 60 degrees C. We do the math, and we're going to get 4.2 times 10 to the negative third J over G times C. Well, that's it for this lesson. You guys be snarly, and we'll see you back here at Moosey Chemistry.